guys, today we're going to be talking about weathering, and the two processes of weathering are chemical and physical. Now this is one of those notes that you're going to want to write some stuff down, and just a suggestion, grab a piece of paper, grab a pencil or pen and start writing some stuff down, and I'll point out some things that you're going to want to put down on paper. The reason being is because I'm going to be asking you some questions in the classroom about this stuff, so you want to have this on paper and ready for yourself in the classroom when you get back here. Okay, so let's start just by looking at the rock cycle. This is something that we observed and looked at a little bit a while ago when we were talking about the evolution of rocks and how they change from one type to the other. And you'll notice that right in the middle of this whole entire thing is this process of weathering and erosion, our next unit here. So the process by which we form sedimentary rocks really starts with the breakdown of other rocks. You have to break them down, you have to transport them, and we get what are called sediments, which are located right here. So in order to make sediments for sedimentary rocks, you need to start with these processes. So we're going to kind of go back to what we were talking about a long time ago with the evolution of rocks, the rock cycle, and this is the beginning of the whole thing. Now, weathering can be defined as the breakdown of rocks at the surface. And this is one of those definitions that I would suggest you write down all of this slide right onto a piece of paper. So in other words, get a piece of paper out like I did and write down these definitions. This is one of those slides where you want to put this stuff down if you need to pause to do so. Okay, so weathering is this breakdown. And I want you to recognize that breaking down the rocks into sediments is weathering. We're going to learn about something related to this called erosion, which is not the breakdown of rocks. It's not the same thing. It's actually the transport. And we'll talk about that a little bit later on, but I want you to recognize the difference between the two. So we're breaking them down, and notice where this is happening. It's happening at the surface of the earth due to the conditions that exist at the surface of the earth with the relationship between rocks and the air, with water, with plants and animals. Those things are going to cause a breakdown. Now, there are two different types, what we call physical or mechanical weathering, and there's also chemical weathering. Okay, and these two processes will point out there's lots of different types of physical weathering, and there's lots of different types of chemical weathering, and that's what we're going to be getting into individually. Okay, so I would write down physical and chemical weathering and the types, okay, as we go along here. All right, so let's start with physical weathering. Here's one type of physical weathering that I think you're very familiar with, frost wedging. Frost wedging occurs in locations where we have water present and where temperatures are going to vary above and below the freezing point regularly. So here in Syracuse, obviously we get a lot of precipitation in the wintertime. The temperatures dip below freezing and then might rise above freezing, like for example this week. Okay, the water is going to freeze and then it's going to melt and then it's going to freeze and then it's going to melt over and over and over again all winter long. And in the process of doing that, water is cool because it expands when it freezes, which is really strange. It's the only substance that really does that. And as it expands, it is going to put pressure on the rock. So when this water gets down into these cracks, it's going to expand and push outward, and that pressure is going to break this rock apart. Okay, so that's something that happens a lot around here. The reason we have potholes in our roads is basically because of this process of frost wedging, or it might be called frost action. Okay, now a great location where this exists and happens pretty regularly is a lot of the gorges around here, but this is Tiganic Falls. If you've never been to Tiganic Falls, I highly suggest you go take a road trip either in the winter or the summer. The summertime's great, but in the winter it looks like this. So here you can see, obviously, this ice is building up on the side of that cliff, and as it gets into these cracks and crevices of the cliff, it breaks off chunks of rock and they fall down below, and we have this Talus Slope down here, which we're going to look at in a second. It's all this broken fragments of rock down at the bottom of this valley here. And you can see here, this big slab broke off after one winter, the ice got behind that. That's about 54 feet across there. Big, huge chunks of rock will fall down. And it can be quite dangerous if you're down underneath of that when it's obviously falling. You wouldn't want to be there. But they do close off this section where you're directly vertical underneath of it. So that is Tiganic Falls, a great example of frost action, again, breaking down the rock into smaller pieces, which then can be transported downstream. This is a talus slope. A talus slope is just a pile of rocks that are at the base of a cliff. And you can see they're all just broken up fragments, angular fragments, which have no real organization to them. Very difficult to walk on top of because they shift and move very easily, but they will get transported downhill further, usually typically by streams. Now, if they get into a stream, you're most likely going to run into this process, this other type of physical weathering called abrasion, or stream abrasion in this case. We're talking about breaking down rocks as they collide and rub up against each other regularly over time. And so what we do is we're transporting them typically in a stream, like for example this video right here. And as you could see from that video, those little stones, those pebbles, are bumping into each other, and slowly over time they break down from bigger chunks of rock like boulders into smaller and smaller pieces. And in the process of getting smaller, they also become more rounded. They wear off the edges. I have some rounded off fragments of rock here on my desk. Here, take a look. All right. So these are some rocks that are actually from Long Island, on the beaches of Long Island. You can see how smooth and round they are. All the edges have been worn down, and it polishes the rocks. It's almost like they were in a rock tumbler if you have one of those. So these are abraded by water. Okay, the water is transporting the rock, tumbling them against each other, and on beach this happens. It also happens in streams. Now, this can also happen with wind. Air can pick up smaller fragments of rocks, typically sand size or smaller, and that sand will get transported through the air, and if the wind velocity is high enough, it'll just collide with the side of a cliff and just essentially sandblast the side of this cliff. And you can see where it's been worn out over time, a very long time of doing this, and you're going to start to wear out little holes and crevices in the rock. This is Arches National Park, which you can see in this picture. And that's a type of abrasion because we're colliding sediment against rock. They're just colliding with each other and wearing them down over time. This is a very, very slow process, obviously, to form something of this nature, but it's the exact same thing that happens in a stream. All right, here's another type of physical weathering, which is a little bit more rare. You need a specific type of rock for this to happen. It's called exfoliation. Exfoliation is the expansion and cracking of rock due to changes in temperature and pressure. And this is typical with granite. Granite is very, very subject to changes in its temperature during the day. It'll get really, really hot, and at night it'll get really, really cold. And those changes in temperature are going to cause the rock to expand and contract and expand and contract regularly. And typically the outer surface of the rock will kind of break away from the inside of the rock. And so it's exfoliating, it's breaking off those outer layers. And you can kind of see it's almost like an onion, right? It's got layers to it. So one outside layer will crack off, and then another one will crack off, just due to the fact that during the day, the outside gets hot, but the inside stays cold. And at night, the outside gets cold and the inside stays fairly warm. And so that difference in temperature is going to cause this rock to crack over time and cause the outer layers to peel off, basically. Okay, and here's a great example of this granite dome mountain here, where the outer layers of that rock are cracking off the underneath surface, and these will break free and slide down the cliff and break into smaller fragments, and you get a talus slope at the bottom of this. Now, here's another interesting, cool process of physical weathering. When lava flows into the ocean, it will immediately cool off, and that is going to actually cause it to break and shatter into tiny little angular fragments. and you get this lava that is broken and shooting up into the air and then washing up on shore, and you get black sand beaches. So this is very typical in Hawaii. You can go watch that, and I'll show you a video of that right here. One last type of physical weathering is really from biological activity. In other words, from plants and or animals, where we have them as part of this process of breaking down rocks into smaller fragments. And there's different types. What we call root wedging, where roots grow into the cracks of rocks and apply pressure. And you'll see that especially with sidewalks that might have a big tree next to them. The tree roots will break up the sidewalk, and it'll be all very bumpy and hard to obviously bike across or walk across. So you have to cut down the tree, which is kind of a shame. You also have lichens. Lichens are a type of moss that grows on the side of a rock, and I'll show you. Here's root wedging, right? You can see that broken up sidewalk because the roots are growing in here. This is another example of root wedging where the tree grew right into the crack of the rock and actually helped to expand that and break it free. Neat thing about this picture is the fact that there's really 3 different types of weathering happening in this picture. You have obviously root wedging, but you also have exfoliation. This is granite. This broke free. This big slab broke off the side of the mountain here. And then you also have a little bit of lichen growing on the side of the rock here, these mosses that are growing there. And they're chemically weathering the rock. This is lichen if you've never seen it before. Lichen will grow on the side of a rock and use the potassium and the calcium and the nitrogen from the air, and essentially they take it right from the rock and they weaken the structure of the rock so that it's more prone to further weathering by other means. Okay, so lichen is really a chemical weathering, but it's part of this process. And then you also have, the last one, burrowing animals will grow or will go into the side of a hill or into the ground and essentially open up passageways for air and water to further break down the rock through maybe frost wedging or something like that. Okay, so those are all the different types of physical weathering. Let's move on from there to chemical weathering. Chemical weathering is a natural process that happens as we have exposure to the air or to water, and it is a chemical reaction. We're forming new compounds, we're forming new things on the rock, and therefore weakening the structure of the rock typically. Now, you probably know that if you combine iron with oxygen, you're going to get iron oxide, and that's what rust is. So your car is constantly having this happen because it's made out of iron and it's exposed to the air, and over time your car rusts. Same is true with calcium carbonate. Calcium carbonate, if you didn't know, is the chemical structure of calcite, a very common mineral on Earth. If you expose calcium carbonate to acid, it will form ions of calcium plus water plus carbon dioxide. And all of these things are much weaker than they used to be. And so we have a breakdown of a typical rock that might have iron or might have calcium carbonate into weaker structures. Okay, so chemical weathering is really weakening the rock. Now, there are 3 different types of chemical weathering: oxidation and carbonation and hydration. So we'll just start with oxidation, which is what I just talked about with rust. We're forming a structure from a combination with oxygen, and that structure is probably weaker. So iron oxide, rust, is very weak compared to the original iron that was there. Okay, so it's a much weaker structure, therefore the rock is more prone to further weathering and breakdown. Carbonation is a very commonly asked question, especially with earth science, because calcite makes up limestone, and it also makes up marble. And if it's exposed to acid, which is usually in rainwater, it's going to break down and essentially form a cave. Okay, so limestone, marble, anything having to do with calcite is going to have this process of carbonation take place. And the last type of chemical weathering is hydration. And this is just the absorption of water into a mineral structure, which is really interesting because this is something that's studied on Mars. And currently, actually right now, they're looking for water and things of that nature that might support life on Mars. So they're looking for this process of hydration taking place possibly on Mars or in the past. So what happens is the rock absorbs water and it becomes part of the chemical structure of the rock, and it just forms a new mineral. So anhydrite might form gypsum. These feldspar minerals, this is feldspar, forms a much weaker structure, gypsum. And you know gypsum is a super soft mineral. And if it's much softer, it's much more prone to further weathering. So again, these three processes of chemical weathering are all about breaking down the rock and weakening the structure of the rock. Now, the one, like I said, that's most commonly asked about is this one called carbonation, where you're putting acidic gases, maybe from power plants and things like that, into the atmosphere, which are then going to be carried by wind and then brought down by water, by precipitation down to the ground. And now we have slightly acidic rainwater falling on the surface, which is going to break down stuff like limestone or marble, okay, on the surface. So if you've ever been to a cemetery, a really old cemetery, you'll often find tombstones made from marble, and they're usually really, really worn out because of their long time exposure to acidic rainwater. Okay, and the same is true with limestone and caves. All caves everywhere pretty much are made from limestone. Why? Because the water that's weathering them is slightly acidic, and that slight acidity is going to slowly weaken the structure of the rock, break it free, and it's going to be transported out of the cave. Now, a couple of more things regarding weathering that are, I think, important is the idea that weathering is not going to happen on a regular basis with all rocks. Some rocks are more resistant to weathering, and some are a little bit less resistant to weathering, and so they'll either break down fast or break down slow. And so that's what we call differential weathering. In other words, there's different rates of weathering on different types of rocks. So if something got transported into a stream, like let's say sandstone is very, very resistant to weathering because it's made from quartz. Whereas limestone is made from calcite. It's a much weaker mineral. And so it'll probably break down a little bit faster. So you'll see different rates of weathering and different types of rocks that are going to be getting more weathered than others. And so you might see something like this where you have different layers of rocks that are weaker or stronger. You might see something like this where you have different layers of rocks where some are kind of worn out a little bit more and some are more sticking out and more resistant to weathering. And the same is true with this beautiful picture here in Arches National Park. Some parts of this are a little bit weaker than others. Okay. You might even have a rock on its own, like this picture right here, or my rock on my desk. I pulled this out of a stream. You can see there's some much more resistant layers, whereas this white layer right here is a little bit less resistant. You can see holes in it. Okay, so you definitely have this happening regularly throughout the Earth in different ways. Now, the question that will probably be asked is something of this nature, looking like this picture here. So you have the side of a cliff. We have different types of rocks. They're all called different things. These are pretty common names around here you're probably familiar with, like Marcellus or Manlius, right? These are familiar names. These rock layers, some of them are more resistant, and some of them are less resistant to weathering. And so this question says, which one appears to be the most resistant to weathering? And the best way to answer this question, I think, is imagine if you were rolling a ball down this cliff. Like you're standing up here, you roll the ball down. Where does the ball potentially have the ability to stop rolling? Well, it would be on a flat surface, like right here on Onondaga. Maybe it'll stop there. If it got onto the Schoharie or the Esopus right here, it would roll right down that slope. It's been worn away a lot. But these flat layers that stick out like that are more resistant to weathering. Okay, so wherever you see that flat layer happening, where the ball might stop rolling, right, that's where it's going to be more resistant to weathering. This New Scotland one, it would roll right down there. It's been worn away. All these down here, very worn out. And you can see the layering of these rocks, the type of rock really matters here. This is all shale. This is shale here. This is all shale down here. Notice these ones, these limestone ones, are actually a little bit more resistant than the shales. Okay, so they stick out a little bit more. So the answer to this question would be number 2. Okay. Now, the last thing I want to talk about with weathering is the fact that there are major climate factors that affect what type of weathering will happen and how much will happen. So this is a really good table to write down in your notes. Just draw this and write all the things in it. Let's start with physical weathering. Physical weathering is going to be more dominant in a cold and very humid climate. Humid just means lots of precipitation, lots of water. And that would be true around here, right? Where we have pretty cold temperatures and lots of precipitation throughout the year. And the really dominant factor with physical weathering is usually frost action, okay? Where now we're weakening the rock, we're breaking it down a lot more in the wintertime too. Chemical weathering tends to be more dominant in warmer climates with lots of precipitation. So maybe down in Florida, you're going to have a lot more chemical weathering. You have a lot of sinkholes down there in the limestone, and a lot of more cave formation. Okay, so just recognize that the climate has a major role to play when it comes to the type of weathering and how much is happening. Okay, and what you're going to be doing today is also answering some questions related to this graph right here that kind of relates the idea of precipitation and temperature, which is going to be the factors that determine what type of climate you have and what type of weathering occurs. And you can see the farther up the scale here to the right, the higher the temperature, the more chemical weathering is taking place. If you're in a lower temperature, that tends to be more of the physical frost action kind of weathering taking place. All right, so just recognize that this graph kind of relates to this idea of climate. Okay, and that's pretty much it. We'll be talking about a few more things in the classroom, but hopefully that all makes sense. If you have any questions, just let me know.